Hello, ladies and gentlemen. Today we're going to talk about completing a proof using deductive reasoning. And the simple way to understand deductive reasoning is when you state facts, rules, definition, properties, or theorems, and postulates, and from these facts, rules, definitions, properties, theorems, and postulates, we are able to say a final conclusion. Okay, and this is called deductive. So I need this reason leads to this reason, leads to this reason, and because of all these reasons, I now have a conclusion. And that's basically deductive reasoning. So we're going to do a quick example here on an algebraic proof. So this is something you should be comfortable with. You should know how to solve for x. So in essence, we're just solving for x, but we're going to do it in proof form just to get us comfortable with how proofs work. So on the left, you're going to put a statement or what you are doing. On the right, you're going to put why you are doing it. So in this example, we're going to use this bank of reasons. These reasons go here. Okay, you should be comfortable with this work here. What is not comfortable is the reasons, the why. And this is something that we have to get comfortable with and get used to. So let's go ahead and start. So our first statement, if you notice, is actually just what the problem was. This was given to us. So the reason we can write this down is because it was something given to us. So our first reason, and this is mostly how proofs start, is you're given. This is information that was handed to you. So right here we are going to write given. Now from the statement 1 to statement 2, we have to figure out what happened. So if you notice, we actually added 2 to both sides. That's what we did, and we got this. So that reason we did that is a property called the addition property of equality. So this is the hard part, understanding and knowing all these properties. Okay, now from 2 to 3, we have to figure out what happened. So if you notice, we got rid of the 5. 5 is dividing. To get rid of something that's dividing, we do what to both sides? And hopefully you say we multiply both sides. So when you multiply both sides of the equal sign, this is called the multiplication property of equality. So we continue make the connection. Now we're connecting step 3 to step 4. We have to figure out what we did. If you look, I got rid of the 4 by dividing to both sides. So to divide both sides, that's the division property of equality. Now what I want you to notice here is we started with this, and to end our proof, our last line should be what we're trying to prove. So if you notice, we're trying to prove x equal to 15. If you look at our last line, we have x equal to 15. Therefore, our proof is done. So to sum this up, this type of proof here is called a 2-column T-chart proof, where one column has statements or things you can say about your problem. The other column has the reason you are writing down this statement. Most students have trouble with the reasoning. It's because it's a lot of vocabulary stuff you have to remember and memorize. So if you do have trouble with proofs, it's mainly because of this part here. So hopefully we get comfortable with this and we can move forward. Okay, so here's an example of a geometry proof. We are not necessarily going to fill this in. I just want to make sure we are comfortable with the dynamics of the T-chart. So again, on the left side, you would put your statements. Usually it's things that are congruent to each other in geometry. You also could put things that add up to 180 to each other. But on the right side, we must use reasons, facts, definitions, properties, theorems, postulates. For example, one reason that we could put over here, if it works, is something like vertical angles is a property. Sorry, not a property, but a theorem. Okay? So when we talk about vertical angles or corresponding angles, these are all examples of properties, theorems, postulates. We've been talking about triangle sum theorem. These are all reasons we can use, and there's many, many more that you have been exposed to in im2 that are going to come back. But we can use all the reasons we can think of that we've been taught, and we can put them here as long as they explain our steps. Okay? And then last but not least, your last step is always what you're trying to prove. So if you notice this example, my last step is what I'm trying to prove. And the reason is you have to give me a reason. You can never say, oh, because I proved it, or because you asked me to prove it. You would have to give some type of reason. So again, this is just to show you how proofs are going to work. We're going to use a diagram to help us get the statements. And once we have a statement, we have to put a reason down. And it can't be a made-up reason. It has to be a reason you've been taught and have learned how to use. Okay? So we're going to move on. We're going to do some examples of proofs in a little bit, but I want to remind you of certain reasons you can use. So that's what we're going to do next. So as you look, these are some definitions. These are things you can use as reasons to say certain things. Okay? So this definition of congruent segments basically says this. If you know two lines are congruent, then you can say that they have the same equal measure. In geometry, you have to tell me why you can say this. Well, I'm telling you why. It's the definition of congruent segments. Congruent segments mean you have equal sides. Okay? Same goes for angles. If you have congruent angles, you can say they have equal measures, and vice versa. If you have equal angle measures, you can say the angles are congruent. Once you write this statement, you can say it's by definition of congruent angles. Okay? This property here is kind of a logical property. Okay? And the way it works is, I want you to think of it as a chain link. If angle 1 is congruent to angle 3, so when you have this connection, angle 1 is congruent to angle 3. And if you notice, we have angle 1 congruent to something totally different. So angle 1 is congruent to two things. It's congruent to angle 3 and angle 2. We can now say, by association, we can now say angle 2 and 3 are congruent because they're both congruent to angle 1. This is called transitive property. Transitive, think of it as you're transferring your congruence. Because they're both basically equal to 1, they must be equal to each other. Okay? Again, we'll get some practice with that. Supplementary angles. Again, it's a vocabulary word, so we have to use a definition. When we have angle 1 and angle 2 are supplementary, what that really means is the measure of angle 1 plus the measure of angle 2 equals 180. The reason we can say this is because it's the definition of supplementary. Supplementary means two angles equal to 180. So again, these are just some definitions and properties that you're going to have to use, and we got to get comfortable what they mean and how to use them, and being comfortable writing the reasons we are saying these statements. Okay, let's do this example. Again, here's our bank of reasons. I have done the statements for you. We just have to figure out the reasons. So we're going to use this diagram for this example. So in our first statement, we're saying angle 1 and angle 2 are a linear pair. Why can we say that? Because it is given to us. So I'm going to write given. Bam, we're done. Next statement is, from statement 1, we can now say this. Measure of angle 1 and measure of angle 2 equals 180. So this is what you have to understand. A linear pair is when you have two angles, as you can see up here, that equal 180. So when I add these two angles, they're going to equal 180. This reason is why I put this. Measure of angle 1 plus measure of angle 2 better equal 180. The reason for that is what we call a linear pair postulate. When you have a linear pair, you could add them up and put them equal to 180. So we would put linear pair postulate. And I'll just shorthand it just because I'm running out of room. So now we move on to the statement number 3. If you look, statement number 3 says angle 2 is congruent to angle 3. And that is because it is given to us again. So we can use the reason for given. I'm also going to mark that in my drawing so we get comfortable with marking stuff in our drawing. So angle 2 is congruent to angle 3. Okay? Now we move on to step 4. Since angle 2 is congruent to angle 3, how did I go from step 3 to step 4? What happened? And you'll notice is I changed the congruent into equal. Still the same angles, but now instead of talking about the angles, we're talking about the measures are equal. And if you recall, this is the definition of congruent angles. When you have congruent angles, you can then say they are equal measures. So definition of congruent angles. That's why we can say that. All right. So we're still here. Now, how in the heck can I get to step 5? So if you look, we are going to focus in on this idea, 3 and 4. What this is saying in 4, angle 2 and angle 3 are equal. So what equal means is wherever I see angle 2, I can replace it with angle 3. So if you look at our statement here, and I'll highlight it. Wherever I see angle 2, I can replace it with angle 3. So if you look, step 2 and step 5 are almost identical. We have measure of angle 1 plus, in step 2 we have measure of angle 2, but now we know we can substitute in measure of angle 3 for 2. So again, we are substituting, instead of angle 2, we know we can replace it with angle 3 because of this statement. So in essence, we are substituting, instead of angle 2, we are substituting angle 3 into this statement. Okay? And if you look at our reasonings, this is called substitution property. We substituted an equal measure. All right. Again, these reasonings and these steps take some practice. So I know it's difficult, but we're going to keep practicing. So now, from step 5, how did I move on to step 6? Well, if you look, when we add two angles and they equal to 180, this is the definition of supplementary. So we can now say angle 1 and angle 3 are supplementary. If you notice, that's what I'm trying to prove up here. We're trying to prove angle 1 and angle 3 are supplementary. And we have the definition, which is this equation. I can then say, why can I say this last statement? Is because it's the definition of supplementary angles. Again, guys, this takes practice, but what really needs to happen is we got to get really comfortable with what these things mean and how we can use them in our statements. All right, let's do one more example. So we have given angle 1 and angle 3 are vertical angles. So I'm going to highlight those. So angle 1 and angle 3 are vertical angles. Let me clean this up a little bit. So those two angles are vertical angles. So we look at our statement here. Why can I say angle 1 and angle 3 are vertical angles? Because it was given to me. So I'm going to put given here. All right. So again, try to make the connection. How can I use step 1 to get me step 2? Okay. And if you don't see the connection there, then look at the drawing to try to get something from the drawing. So step 1 really doesn't connect to step 2. We actually get step 2 from the drawing. And what you'll notice in step 2, it says that angle 1 plus angle 2 are equal to 180. So I'm going to kind of just color code this real quick. Angle 1 and angle 2 are equal to 180. When we have this situation, that's called a linear pair. So if you look at our bank of reasons, we have what is called the linear pair postulate. We used this before. So we are now going to put down linear pair postulate. Okay. Now let's move on to step 3. Again, try to get 2 to go to 3. And if you can't really get an idea of how to get from 2 to 3, then maybe 3 came from the drawing again. So let's look at the drawing here. And again, we do have another linear pair. And that's what statement 3 is saying. 2 and 3 are also a linear pair. So I can then say the reason for step 3 is linear pair postulate again. And linear pairs always add up to 180, and that's why we have this statement. Okay, so now let's go ahead and look at step 4. And in step 4, what you should notice is we're actually taking these two guys and using it to get step 4. So we have angle 1 plus angle 2 is equal to 180. And we also have angle 2 and angle 3 equal to 180. Since they're both equal to 180, since they both equal the same thing, I can actually put them equal to each other. So if you look, I actually put them equal to each other because they're both equal to 180. Okay? This is called transitive property. Think about it as you're transferring congruence. You're transferring equality. So transitive property. What transitive property says, and I mentioned this before, is when you have two different things equaling the same thing, we can put the two different things equal to each other, and that's transitive property. So last but not least, how can I now use part 4 to get to part 5? So if you look at this equation here in example 4, what happens if I subtract angle 2 from both sides? So in essence, I'm doing this. I'm going to minus the measure of angle 2, treat it like a number. And what happens is these guys would cancel out. And when they cancel out, we have measure of angle 1 is equal to the measure of angle 3. Okay? So in order to go from step 4 to step 5, I've actually had to subtract something. I subtracted away angle 2 to both sides, and this is why we have subtraction property of inequality. Okay? So again, these examples are just to get you comfortable with the format of how do I set up a proof. Okay? Just to get you comfortable with the format. I know we're just going to need some practice on these reasons and just different ways of setting this stuff up. Okay?